So I know directional angles of vectors can be a little confusing, especially when it comes to clockwise and counterclockwise off the positive and negative x and y axis. So let's look at a few examples and see if we can't figure out how to read these angles. And let's start with 80 degrees clockwise off the positive y axis. And so to figure this out, let's start with a simple x and y axis. And let's start breaking this thing down. And so it says it's coming off the positive y-axis. And so I'm going to draw a vector that's going along the positive y-axis. Then it says it's going clockwise. And I know I'm reading it backwards, but just bear with me here. So it says it's going clockwise off the positive y-axis. If we start at the positive y, clockwise would be this direction. Let's think about it. We can look at the hands of a clock. We start at 12, we go to 1, 2, 3, 4, 5, 6, and so on. This is the clockwise direction. So starting from the positive y-axis, we will go clockwise 80 degrees. So let's add our arrows to our vector. And then we can say that this is 80 degrees. And we can say that it left the y-axis in a clockwise direction. And so that's all it means when we read 80 degrees clockwise off the positive y-axis. And how would this actually look as a vector? Well, we would draw ourselves an imaginary y-axis since we're measuring off the y-axis. And since this is a positive y-axis, we'll start by going up, and then we'll go off 80 degrees in the clockwise direction. So we can add our arrows and then add our angle. And so this is what the vector would actually look like if we were to draw it out. And of course, it would have some name. We can just call this one vector A, and we could set it equal to some magnitude, but let's not waste time talking about that. Let's just spend this video talking about directions. So from there, let's go ahead and try another example. And this time, let's say it's 80 degrees counterclockwise off the positive x axis. And so we'll start with a simple x and y axis. And this time we'll draw a vector starting from the positive x-axis. So that's this direction. And then it says it goes counterclockwise. Okay, so this direction is counterclockwise. It's backwards. And so starting from the x-axis, we will go 80 degrees in the counterclockwise direction. And so we can add our arrows, and we can add our angle is 80 degrees. And we can say that it's leaving the x-axis in the counterclockwise direction. And so how would we actually draw this vector? Well, we'd start with an imaginary x-axis. And since it's the positive x-axis, we'll go from left to right, and then we will go counterclockwise 80 degrees. And we can add our arrows, and we can add our angle. That's 80 degrees. And of course, this vector will have some name, and we'll just call it vector B. And that's all there really is to reading directional angles. But from there, let's go ahead and try another example. And this time, I think I want to work backwards. I want to draw a vector that's going a direction, and then we can figure out its angle. And let's actually make it a little confusing. Let's not draw it from the axis itself. Let's draw some random vector going up and to the left, some direction, and some amount. But let's have it start not from the axis, because sometimes the vectors are drawn this way. They're just drawn in some random place, and so it can be a little confusing to figure out where your axes are. But if you think about it, this line will continue parallel all the way to the axis. And so we can figure out what this angle is. Let's say it was 40 degrees off the x-axis, just by continuing the line all the way to the x-axis. Or you could just ignore the x and y-axis and draw yourselves an imaginary x-axis. You will get the exact same angle of 40 degrees. And if we look, what direction is it leaving this x-axis? Well, if you follow it, it's going in the clockwise direction. So from the negative x-axis here, it's leaving to the clockwise direction. And so what would be the direction of this vector? Well, we can write it out as 40 degrees clockwise from the negative x-axis. And how do I know that it's the negative x-axis? Well, it's starting from the left, and left is the negative x direction. And so hopefully this is just too easy, too obvious. But let's go ahead and try a couple more examples. So this time, let's say we're leaving 30 degrees clockwise from the positive x-axis. And so we start with our imaginary x and y axis, and we go through the positive x, which is to the right, and then we rotate clockwise, which is this direction, 30 degrees. And so we can add our arrows and our angle, which of course we just said was 30 degrees, and we can say that it's going in the clockwise direction. And so let's go ahead and draw this the way the vector would actually look. So we draw ourselves an imaginary x-axis, and coming from left to right, since it's off the positive x-axis, if it was the negative x-axis, we would go from right to left in the negative x direction. But to the positive x direction, we rotate clockwise 30 degrees. So we draw our arrows, and of course our angle, 30 degrees. And we can call this one vector D. And actually, let's go ahead and go back and name this last one, which we can call vector C, just to stay alphabetically consistent. And so let's go ahead and do one more. This time, let's say it's 60 degrees counterclockwise from the negative y-axis. And so coming off the negative y-axis, we will start going counterclockwise, which is this direction. So we'll go 60 degrees counterclockwise. We can add our arrows, and of course our angle, which we just said was 60 degrees. And we can note that it was going in the counterclockwise direction. And let's go ahead and draw out our imaginary y-axis to see what this vector would actually look like if we actually drew it out. And so since it's the negative y-axis, we'll go down across this y-axis and then rotate counterclockwise 60 degrees. Now you might notice something interesting here, that both of these vectors are going in the exact same direction. And if you don't see it, let's talk about that. This is actually the same as vector D, this angle as well, even though it is a different angle measured from a different place. But let's think about it for a second. Let's draw ourselves out an imaginary negative y-axis and an imaginary positive x-axis. And let's redraw ourselves vector D coming off the positive x-axis 30 degrees. And so if we come down 30 degrees off the positive x-axis in the clockwise direction, and then we draw this pink vector coming off the negative y-axis counterclockwise 60 degrees, you'll notice that they end up in the exact same spot. So let's go ahead and mark these angles for ourselves. This one is 60 degrees, and this one, let's pick a different type of green. This one is 30 degrees. And this makes sense because 30 plus 60 equals 90. And so essentially both of these angles end up pointing in the exact same direction. And so we can write this out for ourselves. We can say that 30 degrees clockwise off the positive x-axis is equal to 60 degrees counterclockwise off the negative y-axis. So essentially there are two versions of the answer, and either one of these answers would be correct if I were to give you this vector going in this direction. You can measure from the positive x or the negative y-axis, and both answers would be equally correct. And how would you choose which angle you drew? Well, it would depend if you're going off this vector. Are you going in this direction? Are you going to the right and then down? Or are you going down and then to the right? And this is true for all vectors. Every vector has two versions of an answer for its direction. We can say that it's going 80 degrees clockwise off the positive y-axis, or we could say it's going 10 degrees counterclockwise off the positive x-axis. And we could say that this one is 40 degrees clockwise off the negative x-axis, or we could say that it's 50 degrees counterclockwise off the positive y-axis. And so hopefully this made it a little bit more clear what we mean when we say clockwise and counterclockwise off the positive or negative x or y axis.